Welcome to today's Manufacturing Engineering Media webinar. Our topic is Lightweight End Effector Tooling Accelerates Automation. Hello, I'm Jim Sawyer, Senior Editor at ME Media. Before the presentation begins, I'd like to provide some background on what we will be doing today. Our sponsor, DESTACO, a Dover company, has a nearly 100-year history of providing manufacturing productivity solutions to customers worldwide. It is a pioneering manufacturer of innovative material handling tools for any application. During this webinar, you will learn how, by integrating lightweight tooling into production processes, the automotive, robotic, and packaging markets can benefit from faster part handling, improved production levels, and safer working conditions. Our presenter, Robert Patera, has been with DESTACO for 22 years and has held the position of Global Product Director, End Effectors, since July 2012. Previously, Rob held positions of VP of Engineering and Director of Research and Development. Currently, his primary role is leading new product development and product management for DESTACO's End Effector product line. Rob holds a bachelor's degree in engineering technology from Lawrence Technical University in Southfield, Michigan. You will be able to ask questions during the presentation using the Q&A box that will appear at the right of the screen. The box can be maximized, minimized, moved around the screen, and made taller or narrower should you need it to be. Following the presentation, Rob will answer the questions you've posted via the Q&A box. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. Also, if you have questions about any aspect of our webinars, please email me at jsawyer@sme.org. Now, ladies and gentlemen, here's Rob.
Thank you, Jim. And thank you, everybody, for attending the webinar. I really appreciate the time spending to review some of the things that we feel very strongly about at DESTACO, which is increasing productivity of our customers, especially with some of the new products that we're coming out with. And primarily, I wanted to talk today mainly about what we're calling the Accelerate collection of lightweight tooling. Most of my background, just to start, it has been primarily in end effectors in the automotive industry. I have an extensive background in presses and in dies, but also developing and designing end effectors for pick and place of the sheet metal in and out of those dies, whether it be a robotic application or a transfer press application. What I want to make sure that everybody understands is most of these techniques that I talk about today can also be used in aerospace, in appliance industries, in plastic injection mold, anywhere where you're using an end-of-arm tool to load or unload or pick and place material in and out of your production fixture or die. So as I move on to my first slide, again, I wanted to talk today primarily about Accelerate lightweight tooling. It's a reduced weight end effector designed to help you move parts faster in today's high-speed press line automation. And like I said, we focus primarily on the automotive stamping industry and what we can do to increase production in those facilities. Now, the three pictures that I have at the bottom here are typical press room end effector applications. The first one on the left is a standard robotic pick and place. In this particular picture, it's picking up a sheet metal blank, getting ready to load it into the first press to mold it into maybe a body side or a fender or a door. It doesn't matter. But what I want you to take particular note of is the end effector and how it's designed. Pretty much all modular type components, mostly made out of aluminum, using vacuum cups and some type of vacuum generator module attached to that end effector frame and then mounted back onto the face of the robot. That is a typical end effector and how they're designed using modular components. In the past, it's been steel, but mostly in today's automotive stamping industries, we're using a lot of the modular off-the-shelf type components to design and build the end effector. The second picture in the middle is a typical tri-axis transfer press design where the end effector is mounted directly to the frame and shuttles in to pick up the panel, lift it up out of the die, and transfer it to the next station. That one in particular in that picture uses what we call a sheet metal gripper, where it will actually grab the side of the panel, pick it up, and transfer it. There are also other things that I'll show you later in the presentation that will show a picture of a shovel that sometimes is used to gauge the corners of the panel and pick it up that way. Now in the third picture, I'm calling this a high-speed crossbar robot. This is just another version of automation that's used in the stamping industry where they use an end effector mounted to a crossbeam, and all of the end effector components are mounted directly to that crossbeam. Sometimes that beam could be made out of carbon fiber or aluminum, but the components mounted to that are all standard modular type components. Now, the next slide that I pull up is really what we've started to look at, what the customers are telling us to do. And it really hit us very strong when our customers started asking us to help them increase speed. So what we did is we went to our customers and asked, what are you looking for in the end effector? And when we look at weight reduction especially, the first key thing that always came up was they don't want to be forced to purchase expensive carbon fiber or other alternative type materials. And so what that's telling me is most of the carbon fiber that's out there, although the costs are going down, it's still very costly and very long lead times as compared to an aluminum type structure. The second thing is the tooling is too heavy on our automation and on our people. And what I mean by that is when you look at the weight of the automation being on a robot, the heavier that the end effector is, the more taxing it is on the automation or that robot, as well as people on the floor. Now, most of the automotive stamping is still using a traditional manual tool change function where the person on the floor has to take the tool from a storage location and move it to the robot physically himself and put it onto the robot. And those end effectors can get very heavy. So when I'm talking about very heavy for the people, it's really the backs of the workers on the floor that have to take these tools and change them on the floor by themselves. Sometimes they'll need 2 or 3 people to help them carry just one end effector. So we're really trying to look at what we can do with that. The next thing was we must increase production speed to stay competitive. And some of the numbers that were thrown out to us by our customers were they want to increase the speed of their stamping line by 25 to 30%. And we thought a way to do that is to reduce some of the weight of the tooling and take away that weight from the automation so they can go faster. And then the last cloud here that I have is the customers are looking for standard components that can be specified globally with fast delivery. Most of our customers nowadays are global type customers who are doing business in all different regions of the world. So with DESTACO, we're able to use our global network of our people all around the world to help satisfy some of those requirements. So when I go onto the right side of that slide, here's some of the things that we looked at based on the voice of the customer. We want to eliminate the need for high cost, long lead time alternative materials, whether it's carbon fiber or some different types of materials that we looked at. We still want to be able to get a low cost alternative to the existing modular components. We want to reduce the weight of the tooling without affecting holding power, which means the strength of the components used on that end effector still need to be able to carry the load of the panels or whatever part you're picking up and transferring. We want to reduce the maintenance and downtime on the automation, primarily due to the overweight situations on the robotics or the automation. We want to help increase the speed of the automation, and we want to create global standards and stock parts in global regions to help our customers with fast delivery. So what did we do? Some of these things are what we looked at as a development team, and not just in North America. We looked as a team globally with our groups in Europe, primarily Germany and the UK, and also our teams in Thailand, in China, in India, as well as South America. So as a group, we looked at what can we do to help our customers improve their automation. So the first thing we looked at was our material. Customers told us they don't want to buy high-cost carbon fiber. So what we did is we looked at what can we do with different strengths of the aluminum. And we found a higher strength aircraft grade type of aluminum to reduce the clamping wall thickness of our components. Now the picture on the left where it says old block design has been our typical design for a long time. And it's using just a standard aluminum, but in a block style. But what's happened is that style has gotten very heavy. So in using a higher strength aircraft aluminum, we're able to reduce the wall thickness of the clamping area and reduce the overall weight. And it also eliminates that need for having the high-cost carbon fiber or any alternative materials. So first thing we did was look at material. We looked at the higher grade of aluminums that are out there currently, and it's gotten a lot better globally as far as supply of aluminum. And because it's a stronger aluminum, it gave us the ability to reduce the wall thickness without giving up any holding power issues out there. The next thing was just the design. With our machines in our plants now, we've optimized some of our machines. We looked at some different techniques with tooling and fixtures so that we can add more contour to our components. And you can see, again, the pictures on the left where it says the old block design. Again, we've been using that same design for quite a number of years. Moving to some new techniques with machining, we're able to contour our components and just overall reduce the weight, sometimes by 50%. Our bolts, you can see there's a picture of a bolt. And this might not seem like a big issue, but for us it has been. Traditionally, we've used M10 bolts to clamp around our components. And when we moved to the M8 style bolt, it was really a big change for us. And what it did was overall it helped us to reduce the profile of our components without giving up the strength. With the thinner wall and the higher strength aluminum, going to a smaller bolt did not hurt any of the clamping power that we still needed to hold the end effector frame. So we reduced it from an M10 to an M8, and that gave us an overall reduction in the profile. Some other techniques that we looked at was what can we do with the finish of our components, being an anodized aluminum. Would that help us increase holding power just by adding some friction? And in our testing, it really showed a big difference as we anodized and used some different techniques with the anodize. It added just enough friction in the modular components and around the tubing to give it an increase in that holding power. Again, reducing wall thickness, reducing the clamping bolts, and adding some finish to our components help to keep the holding power and the strength in our tooling. Next thing we did was we looked at some of our removable cap clamp locks, and you'll see in the hinge design picture there are some rivets, whereas in the past they used to be dowels or roll pins, and we used a standard DESTACO stainless steel type rivet that's used in our proven technology and our manual clamping product line. We used the same rivet, and it really helped us to increase the strength of that clamp. Again, changing the design, the bolts, the anodize, and adding these different stainless steel pins helped to increase the strength of those components. The tubing, this was a big part of the weight reduction. We looked at reducing the wall thickness of our tubes. Right now we have metric and imperial size tubes, and all the tubes are anodized with a 3 millimeters wall, and it has greatly reduced the weight. In the past we would use maybe a solid bar, or we would use a thicker wall tube that was more off the shelf. But nowadays, again, with the material that's out there, we've really seen an improvement in lead time with a lot of the aluminum manufacturing plants. So it's greatly helped us to look at what can we do with this design. And then lastly, there's a picture of a laser engraved component. Our customers need to know the part numbers and the bolt torques on our components. So what we found is by using a laser engraving machine along with the anodize, it really helps the logo, the part number, and the screw torque to really stand out. And it has eliminated the need for us to put a sticker or anything like that, because the stickers just wind up falling off anyway. So if the customer orders an end effector and there is any kind of a crash or a breakdown and they need to get spare parts, you can easily look at the existing component and see the part numbers and order that online. So it's been a great improvement of our components. The look of the components has been greatly increased, and we've eliminated some of the problems that we've had in the field. So let's talk about some results. One of the key things that we wanted to do was increase speed. And in talking to some of the current customer base that we have out there, we've been able to lighten the components, eliminate the excessive bounce in some of the robotic applications, and they have found an increase in speed of 25 to 30%. And I think in some cases there's been a greater increase. Now in a stamping plant, especially automotive, that could be 1.5 to 2 strokes a minute, which is a tremendous increase when you're talking production for body panels. So when I talk about bounce due to the automation, a lot of times with the heavy end effector, when it picks up the material out of the one die to transfer it to the next die, there is a lot of excessive bounce in that end effector. So the robot will need to stop or slow down to eliminate the bounce before it can go into the next operation. So a lighter tool has helped us reduce the amount of bounce so that the robot can just continue to do the transfer without slowing down. Lighter components have reduced the strain on the automation, and what that means is the robots aren't being overloaded anymore. And I know just as well as a lot of you people on the line that we can overload those robots and just say, well, we can add a little bit more weight to it and try to push it, but you'll put a lot of strain on that robot, and it tends to add wear and tear and a lot of maintenance and downtime. So again, lighter components helps to reduce that issue. Then the other thing too, we're finding that our customers can go to a smaller size robot with the lighter tooling, which most of the smaller robots can go a lot faster. So it's been a great increase in speed, and we've really found a good increase in production for our customers. Ergonomics, let's talk about ergonomics. We have found in looking side by side at some of our old end effector designs to the new ones, we're saving up to 50% in weight. And I'm just talking aluminum against aluminum with old versus new. If I was to look at some of the old steel type designs, it's an even greater improvement in weight. So a big issue on the floor right now is worker safety, just the back strains. So we're really looking at improving a lot of the safety issues on the plant floor just by changing to the newer end effectors. Reduced maintenance, the downtime and maintenance again on the wear and tear of the automation, and then localized support. So DESTACO's global network is really based at looking at 4 different regions around the world, and that being North America, South America, Europe, and Asia. So what we did with the designs that you see on the screen is we've made global designs, metric standards. Some of the customers here in North America still utilize the imperial standards, so we've used that as well. So we use a global design. No matter where it's being manufactured, they're still using the same drawings. So if you're a global company who does manufacturing in all those regions, we can support you in those regions with local stock and also local manufacturing. So our global network primarily has been looking at China to support our Asia region. We also manufacture in the UK and a bit in Germany, and stock in the UK and Germany to support Europe. And we're also stocking here in Michigan, which is where I'm out of. I'm in the Michigan, Detroit area. But we stock in Michigan and manufacture in Michigan. And we also stock and manufacture in Brazil. So we have been able to support all 4 global regions with components and standard designs. So if you're a global company who uses global specifications, you're able to use these types of components for that global spec. So as we go through, I wanted to talk about some of the things that we looked at as far as industry standard. With the new end effector frame, we still need to be able to mount to standard components. Standard components being vacuum cups, pick-and-place magnets, or also sheet metal grippers and venturis. So the first thing I show here is our mounting for the vacuum cups. We've developed the same types of mounts that the current industry is using, mostly a 1/8 G or NPT. There's also 3/8 G or NPT pipe threads, and there's also a square type mount that can be used with all this tooling. So traditional standard type tools use those mounts. So we have to be able to mount to all the industry standards when we come out with something new. The next sheet shows the vacuum generators. There are a couple different ways to mount vacuum generators, and I'm talking specifically Venturi type units, which are vacuum generators over every cup. Typically in the industry right now, there is what's called a spherical ball mount or an apple core type mount. We have both. There's a 19 millimeter apple core Venturi. There's a 28.5 spherical ball, and there's also a 32 millimeter spherical ball. And we've been able to utilize our designs to mount to every one of those different types of industry standards. We have to think about this stuff when you come up with something new. Okay, I talked about the tri-axis type tooling at the beginning, and you can see there's a sheet metal gripper on the right, a cam action style gripper, but also in use with shovels. We have to be able to mount to shovels in typical tri-axis transfer press applications. The customers will make their own corner shovels. Sometimes they call them gauges, but we have adapted standard mounting designs to those shovels that are typically used in the industry. So you might be familiar with some of these techniques, but our end effectors that we've come out with new are able to mount to any style of sheet metal gripper and any style of shovel that's out there in the industry. Now let's talk about mounting to the automation. This is a very key point when you're designing a new cell or a new automation line that's going down your plant. you have to think about how we mount the end effectors to the robot or to the automation or to the transfer rail. So we have to be able to mount to current standards. And we know that the robotics have come out with some good standards. So we have adapted our components by the use of some standard plates that go directly to our tooling. We also have come up with standard mounting patterns to go to transfer rails. So depending on whether you're using a robot or a transfer rail or automation, we've been able to adapt to any one of those standards. And if we haven't, if there's something new that we don't have, we have an applications team that can easily make a custom style end effector or a custom mount for any type of application. Now, I wanted to show a picture of a typical design. This is from our applications team, where they're picking up a body side panel with an end effector that will mount to a robot in an automatic tool changer. It has a main boom structure and two small manual quick change tools at the end. And when I say that it has a hybrid type design, you can see in that little bullet there, what we did is we combined some older techniques with some new techniques. And this was satisfactory for the customer that looked at it because he wanted to do some weight reduction but was afraid to make any major changes to some of the larger tools. So we were able to combine the new lightweight tooling with some existing end effectors and get a nice reduction in weight. And again, the guys on the floor who have to change this tooling, they're very happy to see some of this new tooling come out. So it's a combination of World Tool style design with the automatic tool changer mounted to a robot and manual quick change tooling for the guys on the floor. Lower tooling, I wanted to talk a little bit about the lower rest stations. We can't forget about some of these things because it's an important part of transferring material from one operation to another. If there's a point where you have to drop off your material at a certain point, we can build nest stations with our end effector tooling. Sometimes they're called idle stations or idle buck stands or nest stations or rest stations, whatever you call them. You can use our end effectors to hold the material for the next robot to pick it up and transfer it to the rest of the process. So we have standard components like what's in the pictures here that's shown on the top right. It shows a standard neoprene or urethane pad with a side gauge to gauge the panel. But in the lower right-hand picture, we're using what we call blue slice nest end effectors. And what that is I can contour the nylon, which the blue slice is made out of nylon. I can cut that in our CNC machine, or in our rapid prototype machine I can make it from a rapid prototype as well. But I can contour the area that's holding the material. I can contour that right from a 3D design. And it's really been good to really hold the material or the sheet metal in a precision way, because a lot of times our automation needs to be able to pick and place this very fast, and there's no room for error. So the blue slice material has been able to give us a more precise holding on the nest stand. So I wanted to show a couple of other applications. The first picture on the top of the page here is a standard DESTACO, which is basically a robot that picks a piece of sheet metal from the stack to load it into the first operation. These tools tend to be very heavy. They tend to take a lot of wear and tear. So think in your operations where you're using, where you have to pick a sheet off of a stack. The lightweight tooling can greatly reduce the wear and tear on that particular robot. The left-hand picture is a picture of a plastic injection mold tool that we've done in the past. There is great opportunity for automation in the plastic injection mold industry. We've done a lot of work with some of the automation companies to use modular style tooling to pick and place the larger plastic pieces out of those molds. And then what it does, it just takes it and picks it. Most of the time it will rotate 90 degrees and then drop it off onto a conveyor. So our lightweight components can definitely be used in this industry. The one on the right is a job that we did for an appliance customer, and it's picking up a stovetop and a very typical end effector with a robot. Again, it's a different industry outside of automotive, but it's using the same techniques. In the automotive industry, can be used in the appliance industry, the plastic injection mold industry. The same type of tooling can be used and stocked right in your plant, and off-the-shelf type tooling, and they can actually be built in your plant as well. Our company, we can do full designs with our applications team. We can build according to your specific design. We can pipe and wire also. It really just depends on what type of application you have and what you'd like us to do. But the idea is we can supply a full designed end effector, tested, and shipped directly to your floor, or we can build the end effector from your design, or you can buy components off the shelf from our plant and build the tools right on your floor. So how do you get to some of these components? I wanted to put this slide into the presentation because we've really tried to make good use of our website. I've really taken the time to put all of our components and part numbers right on the DESTACO site, and you can get to the end effector section just by clicking the products and go to the end effector section. You'll see the drop down will show the lightweight tooling accelerate collection. You can click on that. You can go directly to the components. I also added another place on the website where you can show or see some applications, either photos or some videos of how the end effectors work, just to get a better idea of how to use them. We also have a CAD library you can download directly from our website, and we use a system where you can download right to your native format, whether it's CATIA, Unigraphics, SolidWorks. The ability to have the native data is very important and was very important for our automotive customers, so that they have the history. They can create the mass properties of the end effector if needed. That's available. You can also download the catalog directly from our website. It has all of the tooling that I showed in the presentation, the different designs of our clamp locks, the tubing, our vacuum generators. So feel free to download that. And I think lastly is basically my contact information. I have my business card here. You can call me direct, or you can go to our website and our contacts regionally. If you're looking in Asia or if you're in South America, you can go directly to our website and find out our contact information there. And that's all I had. So I really appreciate the time, and I hope this was helpful to some of you. I'm very passionate about end effectors and really passionate about helping our customers increase the speed of their production. So thank you once again, and I appreciate it.
Rob, thank you. This is Jim Sawyer again. I'm going to leave the screen up here in case people want to copy down the information if they might need a little more time. Also, I'd like the audience to know that this presentation will be available on demand at about 7 p.m. Eastern Daylight Time. That's roughly a little more than 4 hours from now, about 4 hours and 20 minutes from now. And all you have to do to access it whenever you wish is follow the same procedure you used to log on to the presentation this afternoon. And please feel free to share that login information with any of your colleagues who might benefit from using this information. With that said, it's time to go to our questions, and we do have a number of these that have come in. Rob, right here, someone's asked, what diameters of tubing does DESTACO currently offer?
Yeah, right now we have in our metric catalog, we have 20 millimeters, 25 millimeter diameter, 30 millimeters, and 40 millimeters. And then the imperial sizes, we have 1 inch and 1.5 inch. And we are looking in the future to go bigger so that for the larger end effectors that are out there, we can actually move to a larger tube, sometimes in the 2.5 inch to also 60 millimeter range. So that's our current library, and we are looking to go bigger with the product line.
Okay, very good. Here's a really interesting question. It's basically, what kind of rapid prototyping technology are you using? First of all, I guess the question is, are you using rapid prototyping technology?
Mm-hmm. Yeah, we are using some of the rapid prototyping for two different things. One for to get a sample. So sometimes if you want to show the customers a version of what you're talking about, we can get a quick rapid prototype, which is more of the layered technology. And for some of the components that we use for production, you can actually use it for, I talked about the blue slice material. There's some new techniques, mainly the layered version, where you download your 3D model right to the machine, and it will print it out directly for you. It takes a little bit, depending on the size. There's different size machines. Our machine is, I believe it's 6 inches by 6 inches by 8 inches tall. So you have to be aware of the size. There are larger sizes, but it gets a little bit more expensive. So that's some of the techniques that we use, and it'll take for an idle nest slice, could take sometimes 6 hours to print. So you have to be mindful of the time and the size. Okay.
And are you printing in plastic or in metal or both?
Right now it's all plastic.
Okay.
That's the version that we have. I know that there's others out there that you can do metal versions too, but for what we have currently in-house, it's a plastic.
All right. Okay, and here's another one. Could lightweight tooling be used in applications other than end effectors?
Yeah. Actually, one of the things that we've done in the past has been for vision camera mounting. That's become very modular as well, so that you can get different positions of your camera. So this tooling has been used to mount to a wall or to a robot frame, and so that's just one version. You can also use it for fencing. Typical fencing can be used with the modular style components as well. And there's different things that you can do with it other than end effectors as well.
And the folks there at DESTACO would be available to help design and integrate those systems if they were called upon.
Yeah, definitely. We have a great applications group that does a lot of end effector design and custom applications. We actually have split it into two different application teams. One team is primarily automotive, and then we also have a non-automotive team that focuses on plastic injection mold, appliance industry, packaging. We do some end-of-line palletizing and packaging type designs as well with this end effectors.
Okay. Now, you talked about essentially ferrous workpieces and ones that use magnets and vacuum grippers to hold the workpiece, pick up the workpiece. What do you do if you have a non-ferrous workpiece? It's very small and the shape is complex so that the typical magnetic and vacuum grippers do not work on it.
Sure, yeah, that was a great question. A lot of the pieces that we have to pick up nowadays are aluminum sheet metal now, or aluminum sheets instead of the steel. So one of the things that you can do if you don't have room for a vacuum cup or you can't use magnets is there are a lot of foam type, they call them vacuum grippers. So the foam type vacuum gripper uses the vacuum technology but with a like a foam material that will contour directly to the shape of the workpiece that you're picking up. And the technology in the vacuum allows it to pick up large amounts of that surface. So if you don't have a specific room for a vacuum cup, you can use the foam style gripper, and it will pick up a lot of different types of shaped surfaces.
So the foam
that's one technique that we've used.
The foam conforms to the shape, and then it gives a larger surface area for the vacuum cup to work on.
Yes, that's correct.
Okay.
Yeah, it's been a good technique that we've used in the past.
Mm-hmm. All right. Lightweight end effectors result in a lower power to weight ratio for automation. Have you done an energy audit to see how much these end effectors save in the way of energy usage?
You know, one thing that we've done is we've really focused, when you're talking energy or air consumption, we've really focused on the air consumption savings, especially with our vacuum generators, our Venturis. I know that we've done some analysis with the robot companies on reducing the weight. I don't have those numbers with me, but I can definitely get an answer to some of those questions. So the key thing that we look for is what are you running as far as air? Air is one of the biggest things that we look at to improve efficiency of the end effector for just energy savings. So we've looked at different techniques. We've actually come out with a product that has gone from a two-line type Venturi where you use one airline for vacuum and one airline for blow-off. We've eliminated the need for the second airline for blow-off and have combined that into a single airline operation, and it's dropped the air consumption almost in half. So those are some of the techniques that we've used. What we should probably do, and this is a really good question, is to work further with the robot companies to find out, in combination with air consumption and the lighter weight end effector, what is our energy savings. So it's a good question. I'll have to investigate some more.
Oh, good. Well, speaking of questions, we are down to our last one from the attendees. And I should add here that if someone wants to go back and view this presentation again in the on-demand format, the ability to ask questions is available through in the on-demand version, and that those questions will be sent to Rob and to DESTACO and answered via email. So if something pops up into your mind later and you want to know more about this topic, please don't be shy. Let us know, and we'll get you an answer. So our last question, what is the typical lead time for Accelerate tooling?
Oh, yeah, good question. The way I look at it is in two different ways. Is it just a component order, or is it a custom designed end effector? Now, a standard component order, because we're trying to do regional stocking to help with faster delivery, if it's just a standard one or two end effector type order for components, it could be 3 to 5 days delivery. If it's a larger program order, such as maybe 10 10 to 12 end effectors. Component order would be maybe 2 to 3 weeks. If it's a custom designed end effector for a particular stamping line, some of those could be 3 to 4 weeks depending on the complexity. But I would look at it that way. Is it a standard small component order? Could be 3 to 5 days. Is it a program sized order? Could be 2 weeks. And if it's a large custom designed end effector order, it could be up to 4 weeks. So it's just a way to think about it. If you're looking at budgeting for the next project, you can look at it that way. That's how we typically look at it.
Okay, well, good information. Thank you, Rob. And the whole presentation was very good. I wish this technology had been around when I worked in an automotive stamping plant some years ago. The lightweight end effector tooling really does have the ability to increase production, raise safety ratings, and save people's backs and reduce maintenance.
That's right.
To help keep you abreast of the latest in technology and techniques, SME and Manufacturing Engineering Media have a host of ways by which you can keep abreast of these factors, including robotics and automation. For instance, in the September issue of Manufacturing Engineering, we will feature articles on cost-effective robots. Then in the October issue, process improvement will be featured. And in the December issue, we will focus on purchasing automation. And upcoming SME events that focus on a broad spectrum of technology include the Canadian Manufacturing and Technology Show in Toronto at the end of September, West Tech in Los Angeles in the middle of October, South Tech at the end of October in South Carolina, and then the big Fab Tech Show in the middle of November in Chicago. Thanks for joining us for this Manufacturing Engineering Media webinar. We hope you found it informative. I certainly did. And Rob, thank you again.
Thank you.